Question 6, and this one's on the factor theorem. So it says f of x equals that there, minus 3x cubed plus 8x squared minus 9x plus 10, where x can take any real value. Calculate f of 2. So let's just sub 2 in. A part 1. So what makes a good exam answer is shown all working as well. F of 2 equals minus 3 2 cubed plus 8 lots of 2 squared minus 9 lots of 2 plus 10, and put it in the calculator. So minus 3 2 cubed, typing in exactly what I've written, plus 8 lots of 2 squared minus 9 lots of 2. Putting brackets around what you're subbing in is a good habit to get into, because if it's negative, which it isn't in this case, but if it's negative, it matters, so get into this habit, equals 0. So before I read on, what I should be thinking is, it's equal to 0, so that means that what we've subbed in leads to a factor, i.e. x minus 2 is a factor. So part 2 says write f of x as a product of two algebraic factors. So since f of 2 equals 0, this implies that x minus 2 is a factor. And I'm going to try and factorise this using the grid method. Right, so there's the polynomial that we're going to factorise. And how I'm going to do that, I'm going to see what I need to multiply x minus 2 by to get that polynomial. So in the grid here goes minus 3x cubed. That's our answer. So what do I have to do to get minus 3x cubed? I times x by minus 3x squared. And that allows me to fill in the rest of this column. So minus 3x squared times minus 2 is 6x squared. Now I don't need 6x squareds, I need 8x squareds. So I need another 2x squareds. That allows me to see what goes at the top here. So I times 2x by x to get 2x squared. And this allows me to fill in the rest of the grid. Minus 4x. I need minus 9x's, not minus 4x's. So I need another minus 5x's, which allows me to fill this in here. So times minus 5. That should be a plus there. So minus 5 times x is minus 5x. Minus 5 times minus 2 is plus 10, which is correct. We can see there's a plus 10 there, so we know we're done. And this is the part where most students miss out on marks. They don't actually answer the question. They don't write things as a product of algebraic factors. So that becomes minus 3x squared plus 2x minus 5. And there, I've answered the question. I've actually written it as a product of two algebraic factors. Right, so moving on, let's remind ourselves of the question by putting it on screen here. There it is there. Using the answer to A part 2, which is just there, prove that there are exactly two real solutions to that equation there. So notice the similarities between that equation and the original. We've just had x in the original equation replaced by y squared there. So now if I let x equal y squared, this is part B, that means that minus 3x cubed plus 8x squared minus 9x plus 10 equals 0. So I've rewritten the equation. Now remembering back to the previous part, we've already factorised that here. So we can deduce the solutions for x. So x equals 2 is a solution. And let's try the discriminant for that one now. So for the quadratic factor, try b squared minus 4ac. Let's actually see if it's solvable at all first. So b squared minus 4ac, I've got 2 squared minus 4 minus 3 minus 5 equals 4 minus, and let's leave nothing to chance, let's do this on a calculator, 4 times minus 3 times minus 5. I should be able to do that in my head, but when you're under pressure in an exam, what you shouldn't do is put extra pressure on yourself by trying to do things in your head. So equal to 60, so 4 minus 60 equals minus 56, which is less than 0, therefore no real roots to that quadratic part. Therefore, the only answer is x equals 2. Therefore, the only answer is x equals 2, which implies y squared equals 2, which implies y equals root 2. So 2 real solutions as we're asked to find. Right, next part, let's remind ourselves of it. It says, deduce the number of real solutions for theta between 7 pi and 10 pi to that equation there. Well, we've already solved this because we notice that the x has been replaced with tan theta. So we know that tan theta equals 2 for this one from the work we've done before. Must remember to put part C there as well. So tan theta equals 2. And really now, it remains just to draw a diagram and deduce the number of solutions from that. So we know tan theta is a periodic function. That looks like this. So there's an asymptote. So it repeats every pi radians. So let's start this graph at 7 pi. Well, there's 8 pi. And let's keep going until we get to 10 pi. There's 9 pi. And there's 10 pi. So 7 pi, 8 pi, 9 pi, and 10 pi. And it said, deduce the number of solutions for tan theta equals 2. So let's draw a horizontal line at 2. There, we can see 3 solutions. So the answer is 3. Therefore, 3 solutions. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.